Welcome to Cloud Essentials, Chapter 1, Cloud Principles and Design. So we're going to be going over some new concepts to some of you. Some of you have been working in the cloud world for quite some time, and others, this is your very first introduction. Either way, this is a great place for us to jump in and start talking about cloud principles and to start to understand what the magic is behind this thing that we refer to as the cloud. So in chapter 1, a few things that we're going to talk about here. We're going to talk about understanding cloud principles. We're going to spend quite a bit of time in here understanding cloud principles because it's very important to make sure that we are all starting from the same place. And then also just to get a chance to really get to understand what this thing called the cloud is and to understand how it works and what makes it work in the background. And then we'll be talking about exploring some cloud design, and then we'll also end up with our summary and our exam essentials, our written lab, and our review questions. But all of the chapters are going to kind of go in this same type of format, and I think that it's a great way for you to understand what you need to study, both to learn things more about the cloud, but then also to understand how to get through the certification. So the first thing that we're going to talk about, and this is kind of how we're starting our class, is with this discussion, the cloud. What does it mean to you? So depending on your background, it's going to mean a couple of different things. Most of us, when we first hear about the cloud, and what does it mean, we think of iCloud, we think of Gmail, we think of the Microsoft Office 365 suite. We think about the things in the cloud where we turn on our computer and we know that what we're working on it's backed up somewhere. It's running out there in this magic land that we call the cloud. And we know that when we make changes to things, it is out there and it's automatically updated. Well, you're going to learn a lot more detail about the cloud in this course. And the very first thing we're going to do is we're going to demystify this thing that's called the cloud. So here in just a minute, I'm going to ask you to hit pause and then start reading. And we're only going to ask you to read the first 3 pages about understanding cloud principles. So why don't you go ahead and hit pause and read those first 3 pages, and then you'll get a better understanding of what the cloud is. All right, so hopefully now you've unpaused and you've joined us back. And so what is the cloud? What is cloud computing? The definition that we're going to go with is accessing remote servers that provide software, storage, database, networking, and other services. And we'll learn more about the other services later. But going forward, your description of the cloud is going to be a little bit different than what you come in with. Essentially, what the cloud is getting work done on somebody else's computer. So even in the early days of the cloud, before we went into things like Amazon, Microsoft Azure, Google Cloud, we had this principle of the cloud. And what it was is in our data centers, we would be running our services. We would have a piece of hardware. We would carve off a slice and we would let people use that. So even from then, it's still a server. It is in a data center. It's just a way that we make one computer act like multiple computers. And we're definitely going to go a lot more into the detail on that. But again, going forward, when someone says, what is the cloud? You're going to know it's actually running on a server somewhere. It is getting work done on somebody else's computer. And in the case that we're talking about here with our commercial clouds, those computers are owned by larger companies. And we'll get into more detail than that. A couple of things that I hope you picked up in the first few chapters of the book. Cloud is still new. Now, it's been around for more than a decade, and we're most definitely doing more and more things with it. But only recently, within the last, 7 to 10 years, have companies and government become completely comfortable with running really large programs out using cloud. So even though they might have experimented with it a bit, it has really just now getting to the point where people know that they can run enterprise workloads out there on commercial cloud. And so even though it has been around, you're jumping into this when it's still relatively new. Now, another thing that I hope that you can pick up on as we are getting started is it's still a little difficult to jump into this alone and start learning everything you need to know about cloud. And so that's one great reason that you're doing a program like this, because there's sometimes it's going to be a little frustrating because when you're learning these cloud principles, sometimes you need to know something before you can be taught the next thing. And it's kind of hard for you to jump on and do that from the beginning. But what I want you to do is don't be intimidated by that. Be thankful for that. Because while everybody out there is getting started in their own way, just know that you're getting an advantage because you're going through it. We're going to do it in a repetitive motion. So the first time we go through the material, it may feel a little bit difficult for you to get into it because you don't know all the little pieces. But then by the second time, you start to get all of those pieces. And so that's something that we're going to work with. So again, I want you to use that to your advantage, and I want you to do it in a way that makes you where you are not intimidated. And then also, sometimes when you get tired of me saying the same thing, please forgive me. That's just repetition, and repetition is good, and that's what's necessary to really jump into this world. So we also have just now started introducing our cloud service providers. This is, people refer to these as CSPs. If you remember, people used to like their internet service provider and then cloud service provider. And so you're going to hear me talk about four most of the time. There are actually others, but really there's mainly four that you'll refer to. Amazon, which is our Amazon Web Services, Microsoft Azure, Google Cloud Platform, and then also OCI, Oracle Cloud Infrastructure. And so as we go through, I will always kind of refer back to those. These are the ones that I work with on a daily basis. And so another benefit of this is if you have questions or anything, I can do some research and get back and help you more. But really for the Cloud Essentials, we're going to try to not focus on any of these one areas. We're going to try to come in and look at them. So again, to introduce these, we have Amazon Web Services, Microsoft Azure, Google Cloud Platform, Oracle that we'll refer to, and then also there are some others. And so I want you to take a look at this article, and I will throw it up on the screen. And then also, if you check your notes, there will be a link to this article in here. So this article is talking about the different cloud service providers, and I think it's a good introduction. Kind of shows you who are the players and what it means. And so if you look down here, I'll let you go through and read the article and pick out some of the other details. But you'll see that Amazon is usually number one. I mean, I should say usually, they are number one. Other cloud providers have growth, and they sometimes might have more growth. But Amazon was the first one out there. There were other people that did storage solutions and throughout there. And Amazon, one of their products, their buckets where they do their storage, that was one of the first ones that was commercially available. But Amazon really and truly was the first one available to do compute out on the cloud. They said, hey, come out here, sign into this web interface. You can create a server based off of a couple of different things, create this image, deploy it, start it up, and log in and use this out on the web. Now, other people jumped in shortly after, but Amazon is still kind of out there first, and they're still riding the fact that they were the first ones out there. And all the other ones you will see, they kind of come in and they also kind of follow suit. And so Amazon will do something, and then Microsoft will come in shortly after. For instance, they have these things called reserved instances, and Amazon did it first, and Microsoft kind of came in and they quickly did it to be able to follow in. And I don't want to bog you down with the details now, but there's, there'll be things like Microsoft has they don't penalize you for paying upfront, partial upfront, or no upfront. You get the same price. And one of the reasons they did that is because they were chasing after Amazon and wanted to be able to offer the same thing that Amazon had. So you'll see that Microsoft, even though they are gaining ground, and there's lots of reasons that people do prefer Microsoft, and then Google has really been. I mean, they were always doing just fine, but now their cloud tools are starting to get better and better, and so people are, kind of learning how to use those products. And then you'll find out like people like IBM and some of the others, they're tapering off. I mean, there'll always be a reason that they will be around and to have products, but they're not doing nearly as good as those top three. So anyway, this is a great article to get started on learning about the different cloud service providers, and a great way to kind of start understanding how do we make the most of this thing that we call the cloud. So when we talk about cloud, you're going to hear us a lot of times referring back to what things were like before cloud. When I first started in information technology, we had mainframes and we had our dumb terminals. And then we got to where computers and PCs were faster and better. So we started doing more and more on the localized level. And then mid-range came in and people kind of went back to saying, let's do as much compute out there as we can, but we still have these really strong computers that were, the ones that were in front of us. And then nowadays, you come in and you look at a computer and you can have the greatest, fastest computer in front of you, or you can have the dumbest, nothing computer in front of you. You can even have like a Chromebook or a MacBook Air, and the computer in front of you is less and less important because we're doing more things out there. So it's kind of like we've come around and we've almost gone back to that mainframe type of world. So whenever again, you'll hear me talk about a lot of things about the way they were before so that you can kind of understand the progression and why we moved to the cloud, and the advantages of having that cloud and doing your work there. So some of the advantages to cloud computing here, customers can pay for only the resources they need, no upfront capital for servers that will be outdated in years, often cheaper alternative, access to resources from anywhere in the world from multiple types of client computers and devices, flexibility and scalability because additional resources can be quickly added or removed, access to newer technologies without someone needing to take a long time to set them up, data protection through the use of enterprise level backups, and then reduce IT staff and administrative cost. So I want to go through these in a little bit more detail. But customers pay for only the resources they want. So this is the biggest advantage to cloud. And anytime you see a question around, what is the biggest advantage to cloud, make sure that this is one of the first ones you're thinking of. You only pay for what you need to use. This is huge. So imagine if I have this little bitty website that I'm wanting to throw out there, and I think it's going to be big, but I don't know. So I put it out on the cloud, and I put out with the resources exactly what I need to run this application. Well, let's say that after I run this application out there, it starts to get really big and I need to hurry up and put out more. Well, I can go get more. I'm on the cloud. There's nothing stopping me from going out and pulling in all the resources that I need. But then let's say I throw it out there and it doesn't do great. Well, then I can shut it down. And as soon as I shut it down, if I shut down all the resources, it completely cuts off the cost. So this is a huge, huge benefit is customers pay only for the resources they need. So no upfront capital for servers that will be outdated in years. As a consumer, just purchasing a computer and you start it, you go get a laptop, you drop $2,000 on a laptop, and within 3 years, it's so slow, it doesn't do anything. Well, that's great. You no longer have to do that in the cloud. You can create what essentially hardware, even though it's not necessarily hardware, it's really software, but it's software that looks like hardware. So we create these cloud resources, and if we don't pay for them up front, so we can throw them out there. And so then if they become outdated, you just shut them down and then bring out, you spin up some new servers with newer operating systems. So a lot better. Now the next one, often cheaper alternative. It is. And the reason they say often instead of always is because you also have to incorporate some cloud principles in order to make this cost effective. So we will most definitely be talking about this more and more throughout this course. But if you go out and you reproduce everything you have in your data center and you create it in the cloud, it may not be cheaper. But the reason it's cheaper to go to the cloud is you no longer have to spin up things and go for what this kind of hardware that you're going to grow into over the next 5 years. Instead, you go out and you put the hardware out there in a way that is exactly as big as you need it. And then if you need to grow, you can grow. If you need to shrink, you can shrink. So anyway, when it says often cheaper, that's why. Access to resources from anywhere in the world from multiple types of client computers and devices. Again, you sign into the web. As we all know, we can do that from our phone. We can do that from our computer. And so the easy way that we can sign in multiple people, multiple devices is another great advantage to cloud computing. And then we have flexibility and scalability because additional resources can be quickly added or removed. Again, I don't want to get into talking about too much of this right now because I still know that some of you, you have some things to learn about the cloud, but you can run services to replace the need for some of the computers you have. And there's always the ability to make it better and more scalable. Again, we're not going to go into too much detail now, but we will before the end of the course. And then access to newer technologies without someone needing to take a long time to set them up, especially in the security arena. There are so many things that you can do in the cloud. And then you can also bring in these other services. So we'll talk about services later, but most definitely a great way to implement things fast. And then data protection through the use of enterprise level backups. We'll definitely talk about backups more, but it's so much easier than the old days where you had to determine how you're going to back things up, where you were going to keep it, how long you were going to keep the backups. Now we can schedule things and do it and change on the fly, and it gives us the ability to spin things back up as we need. And then also reduce IT staff and administrative cost. Of course, that's always the name of the game, is cutting costs as much as you can. And you can really, if you do this right, you can cut your IT staff down considerably. And I don't want you to think of that as a negative thing. That is a very positive thing. So it's going to make you more valuable as you learn about these skills. But the things that we are cutting down are people in data centers doing the same task over multiple companies no longer having to do that. And we'll discuss that in more detail. But the CSPs are explaining to you, they say, don't spend money on the things that do not make you special. Spend money on the software that you're writing and the technologies behind what you're actually doing. Don't spend your time building hardware and network equipment and the things in your data center that don't help you. They don't differentiate you. So we will most definitely be talking about that throughout this course. But when you're talking about the advantages to cloud computing, these are the things that you need to be thinking about and understanding. Why are we moving to this thing called the cloud? Now, there are some disadvantages to the cloud, as with everything. Security. So client data stored on someone else's server. Now, you're going to learn that if you do this right, you're not really taking a security your systems are not taking a backseat to security. It's still very, very secured, but you are taking a risk. You're saying, I'm going to trust somebody else with my security. But we will most definitely be talking about that, and you'll learn how to alleviate people who ask you about this, and you'll be able to put that hat on and be able to describe that. And then you also have potential downtime, but we'll talk about how you alleviate that. But yes, you're moving into another data center that's under somebody else's control. And so you're giving up any control that you personally have. But you're going to learn about availability zones, regions. You're going to learn about how we do that. And then of course, the last disadvantage, you don't own it. That is, you can consider that a disadvantage, or you might consider it a huge advantage. So we'll be talking through that as well. Now, there are many advantages to learning about cloud in the classroom instead of learning about cloud while you're on the job. Number one is some things that you just have to make an assumption of how they work and you just move on. if you're in the job, you don't worry so much about how it actually works. You're needing to get things done, and you just jump out there. But the good news is that you're in a classroom, you have resources in front of you, so it's going to give you an opportunity to learn a little bit more about how some of these things work in the background. So one of the things that a lot of people that work in cloud may or may not actually quite understand is, how does it work? So virtualization is how it works. We're going to watch a short video here on virtualization and how it's explained. But in short, it's how we take one computer and make it act like it's multiple computers. Now, I remember even nearly 20 years ago, there'd be people that would have a Macintosh computer and they would partition the computer and the drive so that they could boot up a Windows space. So I remember looking at somebody's computer and I saw that it was an Apple, but they were running Windows, and I had to ask him how they were doing that. And he was very happy to show me. He partitioned it and he was running a virtual machine. So this concept has been around for a long, long time. But of course, it was Amazon that came out, and all the other CSPs shortly after, that said, let's spin this up and let's make sure it's secured in a way that we can have a machine running multiple machines. Those machines are completely independent of each other, and we'll make that. We'll be able to take this really large computer, split it up into other computers, and let people rent space on this. Last thing on this slide before I go to the next, I do want to point out that you will see in this online version of the class, I'm going to skip through some of these links. You do have access to these slides, and you'll be able to click on those. But a lot of times I'm not going to take the time here. I may make reference to them like I am here to say, if you want to learn more about virtualization, you can click on this link and go in and learn, and it'll take you to YouTube. And of course, you can also do your own search. I mean, we live in a wonderful time of YouTube University where anything that you want to know more about, you can go out there and find videos on. But just wanted to point out that a lot of times I will just kind of make reference to that and move on, mainly because as I'm recording these lectures, I don't want to take up the time to watch the video, and also the quality gets degraded. But I am going to click on these next links here on the virtualization. So on this slide, if you want to click on each of these, please do. But I wanted to go through and take a look at what each vendor declared, what their definition of virtualization is. So the first one we have here is VMware, and we all kind of have to take our hat off to VMware. They're the ones that really commercialized the hypervisor in the way that we make things work in a virtual world. And if you don't know the word hypervisor, don't worry, that's coming up in a slide or two, and we'll refer to that. But here we're mainly just focusing on the definition of virtualization. And again, VMware is the one that commercially made this available. You could buy VMware and put it onto your computer and make your own computer run virtual machines. And then you could also, in our data centers, this is a way a lot of people made virtual work. This is how we took a giant disk and sliced it up into different areas in big computers, and we would slice them up and refer to them as giving someone a virtual slice. So VMware, they define virtualization, create a software-based or virtual representation of application servers, storage, and networks to reduce IT expenses while boosting efficiencies and agility. And then if we go over here to Microsoft, they have a page for virtualization. They also talk about their virtual network and their virtual machines. But in short here, it says virtualization creates a simulated or virtual computing environment as opposed to a physical environment. So virtualization often includes computer-generated versions of hardware, operating systems, storage, devices, and more. You can read more into that. And then if we go over here to Amazon, what is virtualization? It's the technology that you can use to create virtual representation of servers, storage, networks, and other physical machines. And then finally, we'll grab a definition from IBM. Virtualization enables the hardware resources of a single computer's processor, memory, storage, and more be divided into multiple virtual computers called virtual machines. So all of these definitions are good. They complement each other. And so let me get back over here to our slides. So again, this is when we're in this classroom situation, it gives us an opportunity to say, how exactly does this work? So we what we refer to the layer that makes the between the hardware and how we split the hardware up into this we call the hypervisor. So there's also a little video here. You can do your own research and watch different videos on what the hypervisor is, but I will quickly define it as you have two different types of hypervisor. The main thing is that you have a hardware layer, and then the difference between a type 1 and a type 2 is not that really that important to us, but do want to make sure that you understand they're two different kinds. So we have the hardware. This is the piece of equipment that is in a data center, whether it's your data center or whether it's Amazon's data center, Microsoft's data center, Google's data center. It's the hardware that is sitting there in that data center. Now in the type 1, we lay down the hypervisor layer, and this splits it up to where we have different operating systems. And then we set applications up here that reach down in and go into the machine. I shouldn't say they reach down in because actually we install this application on these machines. So this layer here. So if we have these apps and these need to be running on Unix, we can use this. And then if over here we have a Windows server running or some other server, and we use these applications here. So then the only difference here between a type 1 and a type 2 is that in the type 2, we have our host operating system. So we have our hardware, our operating system, and then the hypervisor running right here. And then we have this guest operating system that's running here, where we have applications that are utilizing that operating system. So again, you can do entire studies on hypervisors and all the parts that it requires to make those work. We, of course, are just kind of hitting high level here, but it's definitely something you don't want to skip over, especially as you're learning about Cloud Essentials and you're wanting to be able to show that you have a good basic understanding of all things cloud. This is one of the things that you would want to be able to describe. Okay, so now that we have been through this and we have a better understanding of what virtualization is and what the hypervisor is, go ahead and take a few minutes, hit pause here, and I want you to read pages 3 through 8. This is where we left off earlier, and then also include the real world scenario on page 8. So go ahead and hit pause here and read that. Okay, now that you are back, we've gone through and it was the book describing everything that I've kind of walked you through as far as virtualization, and it goes into a lot more detail than I was. But then now we want to talk about this real world scenario. So hopefully you read that. If not, go ahead and pause and make sure that you read the real world scenario. But what I like about this is a really good example of our book telling us is why do you need to know about the hypervisor? Are you going to be asked a question about the hypervisor? Probably not. Do you need to know detail about the hypervisor? Probably not, but it's always good to understand this. And then also, I like the way the book describes it. You may have a vendor at one of the CSPs that is telling you what kind of problem they're having behind the scenes. Well, if you understand the hypervisor, it's going to make you able to understand what's going on. It's going to help you be able to go to your customer and describe to them what's going on. So it's always a good idea to make sure that you definitely have a good definition of what that is. And then also, just so you know, there are hypervisor-like opportunities within cloud. And so it's also a good idea to just have a basic definition of that. Even if you don't know it in detail, as long as you know enough to be able to go back and get details later, it's good. So anyway, I think that's a really good addition as to why we're even learning about this hypervisor. Okay, so the next part of your book is a little exercise. It's really just to generate some conversation. This is probably a simplified version of conversation you would have after you actually enter into the cloud world. But this one is just around talking about virtualization. And it's just to kind of get your head around some of the things that you need to understand about this world where we're not talking about hardware. We're talking about running software on top of hardware that's going to make our data center and our machines run more like they are multiple machines and being able to carve off just enough space. Now, again, keep in mind this is a little different than when we're talking about our commercial cloud service providers like AWS, Azure, and OCI and GCP. This is really talking about inside your data center. So just know that you may find yourself in a world where you're talking about these things and you're talking about your own data center. And I mean, there's a slight chance you will, but really the commercial data centers are taking off. And I feel like some of you will probably be seeking out positions to where you're out there working with the commercial, but still great, great thing to understand and something that you should understand. So anyway, on this, if you'll look in your book, read through that, go ahead and hit pause on this, and then read through that first exercise. Exercise 1 walks us through some steps we can take to assess virtualization needs for your user, for a user in your company. So anyway, if you haven't yet, hit pause and then read this, and then I'll kind of run through this. This is one of those things that'd be better if we were in a conversation, but in this case, it's fine. So hit pause and come back when you're done reading. Okay, so in exercise 1, say understand, we're trying to determine what a user's virtual needs are. So, we'll have to ask them questions such as, do you want Windows? Do you need Mac? Is there a reason that you want to run Linux? And a lot of things. I'd say that Linux is probably running about half of the workloads out there, if not more. It's it's a little bit cheaper and it's definitely much better. You don't have to, when you upgrade it, you're not going to see any major changes. So Linux is here to stay and is a great way to run as a base operating system. So anyway, things that you might want to bring up, you want to evaluate their computer to ensure that it can support the VM. You need to make sure you have enough processor and speed and able to run these virtual machines. You need to make sure that you have enough RAM. And of course, you need to make sure that you have enough free hard drive space so that you can lay down the hypervisor layer, the operating system. And then does the system have a fast enough network connection? Of course, that's always something that we're very, very concerned with, even in our home networks. And then consider which hypervisor to use. Is there a version of the hypervisor that's compatible with the operating system? Consider the security requirements. If the guest operating system will be on the internet, be sure to obtain proper security software. And then after all these things have been considered, make the business case for why or why not you can proceed. And this is, this is when you measure the cost versus the benefits and determine what is the best. Now, if you would, go ahead and hit pause again and go read about the service models, and then we'll come back and discuss. All right, so you definitely want to be able to conversationally discuss the different service models. Now, if you're new to this, it seems a little difficult at first, but then once you get a really good understanding of what the different service models are, it gets easier and easier. But you definitely need to be able to speak to them quickly because people will be out discussing the differences between IaaS and PaaS and SaaS, and they expect you to automatically know what they are. And again, it's easy once you get in there and you learn it. But if this is the first time you're going through this, don't worry. We're going to take some time and we're going to discuss each one. So in our service models, the first one that we discuss is infrastructure as a service. So this is where you take virtual hardware that replaces physical on-premise infrastructure. So this is where you go into your cloud service provider and you provision servers just like you would in the real world, except in the real world, you would go out and you would purchase hardware. It would be shipped to you. You would customize it, then you would put it into your data center, rack it, stack it, do all the things that you need to do, and then install the operating system and then go from there. Now, as we've already discussed, there's lots of things that cloud helps us do better in this world. First of all, you don't have to buy servers that you're going to grow into. You purchase servers to run the exact workloads that you have right now. So we'll definitely discuss that more throughout this course. But what I want to explain is when you order hardware, this can be a large time-consuming event. So you order hardware, you have it shipped into your data center. That can take months on its own. And then after you get it, you have to hire the people to bring it in, rack it, put it in the racks where it belongs, stack it, and then add your networking components and all of those various pieces that you need to. So a point I want to point out here when we're talking about infrastructure as a service, this is one of the ways that people move into the cloud. And it's one of the first steps that you could be where you're replacing what you're doing in your data center, but now you're doing it in a cloud world. So I want to point out that even at the lowest level in the infrastructure as a service, where you have your virtual hardware that replaces your physical on-premise infrastructure, you're already taking a huge step. So what we can do here is back in the day when we would order our own hardware, we would order to spec. We would always order a machine that we could grow into, not what we needed now, because we would probably only replace our hardware every 10 to 15 years. So then we would have it shipped. We would bring it into the data center, rack it, stack it, do all the work that required there. And it would take 6 months to a year to order new equipment and have it put in and get it in a position where you had everything on it that you could start using it. So now we're talking about doing this in minutes instead of months. And so some story I always like to tell at this point is years ago I was working on an application. We went out, we determined we needed new hardware. We had it shipped. It was over $100,000 piece of equipment that was sitting on the dock. They were about to bring it in. Something happened. Somebody wasn't paying attention. Somebody stole the hardware off the dock. So it had taken us nearly 3 to 4 months just to get that server there. Well, then the clock started all the way over. We had to go back and order, and we were out our $100,000 because it had already been delivered. And so we had to go completely back and start over. It took over a year for us to implement that new server. By the time we brought it in, did everything we needed to do, install the operating system, install the applications, made sure all the networking was correct, and moved everything over. So it was a very big ordeal. So in an infrastructure as a service world, this what used to take months and months now takes minutes. We go in, we create a new image, we take the image that we had and we make the changes we need to, and boom, we just updated our server. And then there's also other cloud principles that we'll discuss later that maybe even improves that process even more. So I don't want to sound like infrastructure as a service is the low level. It's not. It's a step. It's still a very good way to get people into using the cloud. And a lot of times it's the first way that people do this. So whenever you're talking about infrastructure as a service, it's essentially taking everything that's in your data center and doing the same thing that you would do, except you're doing it inside of a console in one of the cloud service providers. And you're creating images and you're placing them out there. And the best part is you're only paying for them as you use them. If you don't want to pay for them, you can shut them down and you no longer pay for them. So lots and lots of benefits to infrastructure as a service. Then our next one, platform as a service or PaaS. So what we do is we add to our infrastructure as a service, and we include the operating system, the database, the services, and development tools. So a platform model is saying, I'm going to be in the cloud. I'm going to create my servers that I need to create, but I'm also going to take advantage of some of the cloud tools that are already out there. I'm going to take advantage of the fact that I could use some serverless tools instead of putting them on a server. Or I can use some services to replace some of the things that I had to have a server. For instance, let's just take like an email server. Instead of having an email server in our system, we could utilize a service with one of the CSPs and pay for that service as we use it. And so therefore, we would be using a service instead of a server, and it's much cheaper. And we don't have to ever upgrade the server. We don't have to go in there and take care of that. So that's just one example. So remember, we started out with infrastructure as a service. Now we've moved into platform as a service, and then the next step is software as a service. So what this does is it adds to everything that we were using as platform as a service, but it's where we start using software as a service. So a good way to think of this is like Google Docs. You sign in and you can sign in and you get an email and you have drive space. You can use Google Docs, Google Sheets, presentation. You use all of those services, but you don't have to update an operating system. You don't have to manage the server that it's on. So this is the ultimate step when migrating people into the cloud. Because I mean, as you notice, when you go out and you get Google, if you're not using it on a really large schedule, on a really large scale, you can get it completely for free. Most people have a Gmail account and they utilize some of the drive space. And then even if you want to increase that drive space, it's very cheap. You go out and you say, I want a terabyte for a year, and you pay $9 or something for it. It's very cheap and easy. So again, even at a corporate level, software as a service is a great thing to be looking for and looking for those opportunities. So again, when you're going through this, read the book material, but then also make sure that you can have a conversation about these. And if that's in the mirror or talking to your spouse, but explain to them the difference between an infrastructure as a service, platform as a service, and software as a service. And again, you need to be able to just automatically think about those things, because there will be conversations out there where people expect you to understand that moving from an IaaS to a PaaS is what all is involved in that, and it will help make you a better business person and IT person. So the next thing we're going to do is look at exercise 1.2. It's a pretty simple little exercise, and one that I'm sure most of you have already done. But I do want to go ahead and point this out. It's a great little example of software as a service. So one thing that I always mention when people are trying to determine what type of cloud environment they're in, if you have no idea where the server is that's running your applications, then you're probably on software as a service. So in this case, we're going to look at google.com, and this is going to give us a really good view of what a software as a service environment looks like. And then also we're looking at this here on the bottom of page 12 with exercise 1.2. So I'm just going to hit the highlights of this, but if you would, I think you should definitely read through that and make sure that you look at all of the different areas in here. So again, most of you have already done this. You come in, you sign up for a new Google account. You click up here in the upper right hand. If you don't have one, it'll let you create a new one, and you can go through that step. And then the next thing we're going to do here, so this is the Google page. So we go here and we click on this little area up here. And these are our Google apps. Now, if you've never looked at these, you really should. There are lots and lots of good free apps here, things that you can do. You can look at Google Photos, Google Translate, which is really neat. If you don't have that, it's a great thing to have on your phone. You can speak one language into it, and it will turn around and give them a different language. And then you can also, somebody can speak that language back into your phone. You can read it and hear what the words are. So another great app. Also, chat is a great one. You can chat with other people that have Google accounts. Google Meet, completely free application that you can go out and have meetings and have people jump in. Of course, your Google Calendar, Play, and then YouTube, of course, many years ago was purchased by Google. So that's another one that you can sign into utilizing your app. So again, this is one of the best examples of a software as a service. So if you remember, we talked about platform and infrastructure, but then software as a service is when we come in here and all we do is use the applications. All right. So your book also goes into other service models. We talked about the big ones and the ones that we need to talk about and learn about for cloud and be able to speak to. But really, just about anything can has that as a service. So you'll notice that it's capital whatever the item is, and then smaller case for as a, and then the big S for service. So some of the ones that your book talks about, and I would go through and read these. And it's a really good idea to add to your vocabulary and be able to speak to these. But a lot of these you may or may not see, but definitely just know that you can use as a service with just about anything. So some of the things like business processes as a service, communications as a service, desktop as a service. That one is a big one. Data as a service, database as a service, disaster recovery as a service, functions as a service, hardware as a service, information technology as a service, monitoring as a service, network as a service, pretty much anything and everything as a service. So a little quick review here. Remember the big ones: infrastructure as a service, platform as a service, software as a service. Again, the reason that we focus on these are how we talk about things in the cloud. So you can move any application into the cloud from your data center. There's, even if you have to use older technologies, and we'll go into more details on this, but there's even services out there that make it look like you have a tape backup of your servers. And of course, it's not actually tape, it's backing it up into something else, but we have these applications that are written in a way that we can't change the back end services. So you can, as you can imagine, there are services out there for just about anything. So our infrastructure, remember, infrastructure is kind of replacing your data center and utilizing a cloud service provider to build the things that you used to have to order physical equipment and put into your data center. And then the platform as a service, where we take a little bit different step and we start utilizing some services and some things that remove the need for us to have a server running with an operating system and all of the things that we have to manage that. If we can move to a platform as a service, we can do things a little cheaper, and we don't have to worry about upgrading things such as operating systems. And so just a little bit better way of utilizing cloud. And then, software as a service, we just walked through this with the Google example. When you use software as a service, that is the really and truly one of the cheapest ways that you can do this. For consumers such as us, we don't even pay for the use. We go out, we sign up for a Gmail account, and if we keep the use down enough, we can store some files out there. We can do things. We can edit the files. And again, we walk through all the different services that you had, including being able to jump on the meetings, to do video. So software as a service is kind of our ultimate goal when we're talking about moving into cloud computing. All right, the next thing that our book goes into is our deployment models. So we have a private cloud, which means it's on-prem. So what this means is private cloud is in your data center. It still might be a very robust cloud environment. You may have virtual slices. You may do everything that the cloud service providers do, but you're doing it all on your own. So you own the hardware. You own the building that the hardware is in. You own it all. It's your data center. So this is called a private cloud or on-prem. And then the next one that we talk about is a public cloud. So this is where we go into like our commercial CSPs, third-party companies like Amazon AWS, Microsoft Azure, Google GCP. These are probably what we really think of more when we think about cloud nowadays. Some people are definitely still doing private cloud. There's lots of good reasons to do that, especially if you have an ultra secured environment. And then also if you have reasons that you have to have the control of the data center. But as a lot of these controls are being lifted, large companies and government are moving into this public cloud. And again, what's great about this is you can go to the people like Amazon, Azure, Google, and you get those resources, and you get to have the latest and greatest technology available to you utilizing these companies. And then the other deployment model is called hybrid. And again, hybrid, all that means is it's a combination of both. So you would have some things that are inside your data center, and then some things that you're utilizing the private cloud and the commercial CSP. Next thing we want to discuss are some cloud characteristics. So NIST published a principles for the cloud, and their definition of cloud is cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So what this is saying is that a cloud is a way to sign into an environment through the internet, provision resources that you want to use, including storage, servers, databases, networks, and all of these things you provision online on demand. And then some of the characteristics, they're elastic. We'll be talking a lot about this, but they can grow and shrink based on needs. Self-service, meaning they're on demand. Scalability, so this is how we scale geographically. And we'll go into more detail about scalability, but we can scale and give resources more um, strength, more power, and then we can also scale out. And again, we have a whole lesson that we'll talk about this, but we can scale up or we can scale out, meaning that we could duplicate resources. So we'll discuss that. And then also broad network access, so available over the internet, and then pay as you go. Again, this is always going to be one of the top things. What is the benefit of moving to the cloud? It's to pay as you go. You only pay for the resources that you need. And then also availability, meaning it's available at all times, not doesn't go down. And of course, these data centers, there can be issues. They can go down. There can be problems, but we can architect our cloud environments to recover quickly through these. And again, we'll be talking about that throughout the course. All of the cloud service providers agree on the definition of the shared responsibility. As a matter of fact, you'll see if you're signing into any one of the CSP's websites and look up shared responsibility, you'll be able to see that they each have a pretty similar graphic, and we'll walk through that here in just a minute. But there's an old network technician adage that says a server is perfectly secured until you install a network card. And what this means, I've heard this well through different areas as well. Software engineers say that the applications are perfect until you let a user use it. But what it's saying is you can provision servers and everything is great until you give people access to the server. And then as soon as you try to do some things in here and on your server, you're going to run into problems. So in the shared responsibility model, the CSP and the client share security duties, which improves the overall security of the system. And the cloud service provider is responsible for the security of the cloud, while the client is responsible for security of what's in the cloud. If you want to kind of pause this maybe and go out and search for shared responsibility model, you're going to find several different definitions. So why don't you go ahead and spend a few minutes and go out and search for that. And then also, while you're looking, if you run into some of there are people that go out and they record videos where there's music behind it and they sing songs about shared security model. Go ahead and take a few minutes to search for some of those. All right, now that you're back, the shared responsibility model. Again, this one I believe was probably pulled from Amazon just based off the colors and what I'm looking at here. But everybody agrees of the different models. And you can find this. You can find this for all of the cloud service providers. You can also find this. Some companies put the shared responsibility model out there to ensure that people understand. So really, what this is saying is the customer is responsible for what's in the cloud. So if you put your data out there in the cloud and you lock it down, you're in control of that data. So the data, the platform, the applications, identity and access management, the operating system, network and firewall configuration, and the network traffic, file systems, data encryptions, and integrity. These are the things that the customer is completely in control of. But if you move into one of the commercial CSPs, they are taking control of some of the responsibility. So the cloud provider is responsible for what is of the cloud. So the things that the cloud provider is in charge of, think about this. They're in charge of the data center. They're in charge of the physical parts of the data center, including the computers, the security of the building, everything that is works there for their networking. And so some of the things that are included in that are regions. And we haven't really talked about regions yet, but we will. But regions are a geographical location, and there are multiple data centers inside these regions. called availability zones. And then we also have edge locations. You don't need to know what that is yet, but we will most definitely be talking about edge locations throughout this course. And so the cloud provider is in charge of all of those parts, including the compute, the storage, the networking, and the database, everything that you purchase from them. But then remember, the customer is responsible for what's in the cloud. So one thing that they'll say is, will they build the door, but if you don't lock it, it's your problem, not their problem. As a matter of fact, if you sign in and you create you get a root user with your account and you lose that root user password, the cloud providers cannot help you. That is your responsibility. So this all falls within this identity and access management section. So we'll be talking about this more and more, but again, just kind of introducing this concept of the shared responsibility model. So the next thing we're going to talk about here is cloud design. So we're just now beginning this subject, and we're going to spend the rest of this course talking about cloud design and things that we put in to ensure that our applications and our infrastructure are resilient, recovered, secured. We'll be touching on all of these, and that'll be part of what we're discussing all the way through. But in chapter 1 here, we're talking about cloud design, and we're just kind of introducing this subject. So a well-designed cloud solution can save a company money, If you don't do a good job of designing your solutions, you can cost the company money. So we'll talk more about that. But some of the ways that we can save money is no sunk cost, no upfront cost. So the examples where I was talking about where you order hardware, you bring it in, you have multiple people that touch it, multiple people that perform the networking task and rack it, stack it, ensure that the room is cooled, all these little pieces out here that come together to ensure that we can bring a server in, hook it up, and use it, to now we're talking about cloud, where it's no longer, we're not in charge of any of that. We're not responsible for any of that. We make a few selections, we deploy a server, and we didn't have to spend any money up front. And then we also have faster and better access to data. We'll be talking about this, but there are so many better storage options out there with cloud than we have available to us in our own data centers. And then now we're going to focus on the third major area, which is recovery. So the first time we talk about recovery and high availability, this is one of those things where I was explaining to you that when you're jumping into cloud, you have to know something before you can start talking about the next thing. And when you're first starting, it's kind of hard to jump in because you have to jump in somewhere, learn a little bit, and then the next time you hear it, it makes a little more sense. And so it requires a lot of repetition. So don't worry, you're going to get repetition here. But whenever this first time, I'm going to have to explain a few things as I walk you through the cloud, the benefits of having recovery and high availability. So first of all, recovery is how long it takes you to recover if you do have a fault. Availability has more to do with trying to make anything that goes on in the background where things stop working, trying to hide that from your customer. There's no reason the end user needs to know there's any problems. With high availability, we put things out there and we have automated failover in things so that even if there's a major issue in one part of the application, the customer doesn't have to know it. So the way we do this is with redundancy. And so the way that we build this out, and so here's where I'm going to give you a very quick definition of something that we will go into great detail about. Availability zones. So I mentioned to you that regions are a geographic location, such as Northern Virginia. And then inside Northern Virginia, you have multiple availability zones. So these are the data centers that make it to where you have things running in one data center, and if something happens to that data center, you automatically fall over and go into another data center. Again, I'm just kind of breaking open that conversation. We will spend a lot more time talking about how this works and how close these data centers have to be in order to give you zero latency failover. So, but what we do is we have these multiple data centers, and even within the data centers, we can have failover and put things in place to help us design systems that work and work all the time. So, we might have to, with our redundancy, we might have to duplicate hardware, and of course, then our network redundancy, geographic redundancy. That whenever we say geographic, that's more like if something happens to a certain area, if there's flooding or power outages. We build our grid in this country in a way that it won't impact everybody. It just might hit in certain areas. And then we also have our software redundancy, data redundancy. And so all of these come together to create a highly available system. So whenever we talk about high availability, that's what we're referring to. And then if you're looking through your notes, I do have a video here as an example, pulled one from Oracle for their high availability. So please click on that and watch that video as well. And then the last thing we're going to discuss in chapter 1, and be sure and read through the last few pages of this chapter, is disaster recovery. So whenever you see DRBC or DR, this stands for disaster recovery and business continuity. And so this is the ability to become operational after a disaster. So there are there's a complete study of disaster recovery and business continuity, and we're just going to scratch the surface in this. But just think about how much easier it is with cloud. So disaster recovery, let's say that we have a data center in Kansas, and then a tornado comes through and it damages that data center. Or even if it doesn't damage the data center, it does something to the electrical grid. There's a disaster. Kansas, our data center in Kansas cannot be reached. So what we should do is have somewhere else, somewhere geographically displaced from where we are, to ensure that we can run our services there. This is the concept of disaster recovery. And I've worked for many companies, and they all have disaster recovery plans. And there's like I said, there's complete studies of this. But when we're talking about cloud, think about how much easier it is now. So we have things built in a certain geographical location, and when you build out your things, you build them in a certain place. But then you'll probably go somewhere else in the country and select another data center that you're going to run your stuff in. We call these regions. So in a cloud world, it's a whole lot easier for multiple reasons. Number one, it's easy to just pick your hardware up and make a copy of it and put it somewhere else in the country. I mean, we can do that in minutes now. It doesn't take months. But then the other good thing is that we can also, even though we probably will use internet traffic for a lot of the things that we're going to do, we don't have to. We can use, like if you're in Amazon, you can use their backbone, not the internet backbone, in order to touch between different regions. Same thing with all of the CSPs. But so whenever we set these up, it's really easy for us to fail over from one side of the country into another side of the country. So that's another great reason to go into the cloud. And again, think about the expense. If I'm running a data center, maybe I have a few $1 million sunk into my data center, and now I'm talking disaster recovery. I have to go drop another few $1 million into another location and hire people. So it'll get very, very expensive quickly. But with cloud, it's just a matter of building things somewhere else and then ensuring that we put everything in place in order to fail over. Now, as you're reading through this chapter, I want you to also notice some things like RPO and RTO. These are important disaster recovery items because you need to have those conversations. And all of these go on with your disaster recovery planning, where you pull people together and you say, look, what is our RPO? Is our RPO that we need to have data and everything ready to go from 5 minutes ago? Or is half a day okay? Is a week okay? So what this does is this goes into your backup plan. You figure out, do I need to have a point in time? What is an acceptable point in time for me to be able to roll things back. So I'll tell you, 25 years ago, it was perfectly acceptable to tell a group of users, like if they were using an internal application, to say we had an event and we lost data. We need everybody to do the work that they did yesterday. So you come into work today and just do everything that you did yesterday because our database has backed up. You can't say those words anymore. That's not acceptable. Now, people have an expectation of, even if you said you lost the last 5 minutes of data, that might upset them, depending on what it is. But these are the types of conversations you have to have when you're setting up this disaster recovery plan. How far can we go back? And then when we get it back, what is the acceptable amount of time in order for that to work? All right, so we have now completed chapter 1. So in summary, a few things if you'll remember, we talked about virtualization and how that works. We also talked about the hypervisor, and we understand that the hypervisor layer is the layer that's most important and able to make virtualization possible. It essentially is how we take one big machine, break it down into storage and an operating system, and a way to make multiple machines run off of that hardware layer. And of course, these are completely independent of each other. Something going on one server has zero impact on the other server. But if something happens to the hypervisor level at all, everyone would be impacted. So again, things that you don't necessarily have to know to be working in a cloud world, but it really helps you a lot to understand how those things work. And it can help at many different levels. And then we talked about service models. We started with infrastructure as a service, platform as a service, and then talked about software as a service. And we also talked about all of the other service models. And again, as I've mentioned, these are things that you really need to know well. You need to be able to switch gears in your mind and be able to talk about these and to understand the difference between an infrastructure as a service, platform as a service, and for sure, difference between a software as a service. Then we talked about our deployment models, including the public model, private model, and hybrid. Just remember, our private model means that we own it. We own the building, we own everything about it, and we're working in our own world, creating our own cloud. Public is where we go out to someone like AWS, Microsoft Azure, Google, and we build a environment out there on the cloud service provider. And then hybrid is just a combination of both. And there's a lot of people are now moving straight out to commercial cloud, but there's still some use cases where people have a requirement to be on a hybrid. They may have reasons that they have to have control of some of the things, or maybe they have applications that are running that are so old they can't move them. So there's various reasons why you have that hybrid model. And then the last few things we talked about were cloud design and the things that are involved in that area. A little disclaimer on the exam essentials. These are at the end of each chapter, so if you'd rather open up the book and just read through these, feel free to do that. The only thing that I'm going to add to that, I'm going to open up each exam essential, read through it, and then from there, I'm going to give a little bit more commentary. If I have anything that helps you remember how to memorize these, I can. And what the exam essentials are. These are again, they're at the end of every chapter. It talks about what exam essentials we went through in that chapter. And these are the things that you have to know if you're going to sit for the exam. So you can use them as flashcards. I have them in the slides. You'll be able to run through them and do them just like I'm doing on the screen. And it'll be something that you can do for all of the chapters in order to do like flashcards. You can pull them up and make sure that you know what each of those sections are. And then it also gives you an idea of what you still need to study if you need to. But like I said, I just want to make sure you know that, if you don't want to sit here and go through these with me going through them, that's fine. You can grab the back of the book and read through them there. Chapter 1, Exam Essentials. So these first few are a review of everything that we've learned in there about the different as a service models. And so the first one here, what is a SaaS model? Software as a service means that the CSP provides software for a client as well as the underlying hardware needed to run software. Popular examples include Microsoft Office 365, Google Docs. And so these are the things, remember I told you that if you don't know If you can't point to where the server is, that means you're running something as a service. And so these software as a service items are just like that. Then the next one we have is infrastructure as a service, or IaaS. Infrastructure as a service setup. The CSP provides hardware infrastructure. This often means that compute, storage, network capabilities. So remember, IaaS, this is how we replace our data center. We can go in and instead of ordering equipment, we can deploy equipment inside of our CSPs. And then we also have platform as a service. So platform as a service, the CSP provides both hardware and development platform that includes software development tools such as runtime environments. This lets the client focus on software development while the CSP manages the hardware and development. And we want to know what the 3 cloud deployment models are. The 3 deployments are public, private, and hybrid. You might also see literature that refers to multi-cloud environments. Multi-cloud refers to having multiple clouds doing the same or specialized task and not to the deployment model. Be able to list pros and cons for each of the 3 deployment models. So public cloud means that the client does not need to invest in hardware that will go obsolete in a few years, but the downside can be the lack of control and security. Private clouds allow the company to retain security and resource control, but usually cost more because of the hardware replacement lifecycle. Hybrid clouds are the best and the worst of both worlds because they combine features of public and private clouds. Know the 6 characteristics of cloud. So clouds are elastic, provide self-service, offer scalability, have broad network access, and may offer pay-as-you-go and have high availability. So usually whenever you think of cloud, the very first one you think of is pay-as-you-go, because that's the reason that people are moving into the cloud. But then also all of the other pieces, they're elastic. They can grow and shrink on a as needed basis. You can do all of these things yourself. They scale very easily, and then they have a broad network access. So these are the 6 characteristics of cloud, and you want to be able to speak to all 6 of these. Then we have to want to be able to explain what it means for cloud to be elastic. Elasticity within the cloud means that the cloud's resources can grow or shrink as the client's needs change. Clouds can do this because they utilize resource pooling. Sometimes you will hear this called rapid elasticity. So here's what you think of. Let's say that we have a system and we have 1 server, and as long as we have less than 5 people on it, it works great. The application is responsive and everything works good in the app. But then we notice that when we start adding 6 people or 7, everything starts to slow down. So what we can do is we can grow the environment. We can deploy a second server. So we'll talk more detail about how this works later, but here what we're talking about this concept of elasticity. If I have 5 people, I'm running on 1 server. I have 7 people, I'm running on 2 servers. Then 15 people, I have 3 servers. I can grow that out. And then at the end of the day, as people quit using my application, I can also check and say, okay, I only have 10 people on here now, get rid of the 3rd server. Okay, now I only have 5 people, get rid of the 2nd server, and then so on. So you can grow and shrink. That's that concept of elasticity. Now we want to be able to describe what self-service means. So in a cloud environment, much is automated. This includes allowing clients to request or access additional features without requiring intervention from the service provider. Be able to explain what scalability in the cloud is. Scalability is closely linked to elasticity. It just means that the clients have the ability to use more or fewer resources as needed. Then we want to be able to describe what broad network access means. So cloud client can access resources regardless of the hardware or operating system they run. This can mean access for desktops, laptops, mobile devices running on Windows, Mac OS, or mobile OS, like iOS or Android. Now we want to be able to explain what pay-as-you-go means. So cloud providers track client usage and charge them for the services they use, much as public utilities do. So in some payment models, clients only pay for the services they use, which is called pay-as-you-go. Again, this is one of the biggest strengths of the cloud. You can move something out there, you can use it, and if the idea you have grows, then you can make it get bigger. But if you throw something out there and you thought you were going to have 1 million users, but it turned out you only had 100,000 users, you can shrink those resources and pay less. But the good news is that when you only pay for things as they're running, so you can throw it out there. You start out, you're paying for it, and you can determine if you want to pay for more or if you want to bring it in and pay for less. Now we want to be able to describe what availability means in the cloud. It means that resources are available whenever the client needs them. Most commonly, you will hear this referred to as high availability. So the goal for the CSP is to provide uninterrupted service. So we'll definitely spend some time talking about this, but when we build things, we put things in separate availability zones. So if something happens in one area, it will automatically fail over to the other. And when I say fail over, I mean sub-second fail over. So if you build your applications correctly, you can build them in a way that if there is a small outage, a large outage, it doesn't matter. You can build them in a way that the customer is never even aware that there is an outage. Next, we want to understand how shared responsibility model works. So the shared responsibility model pertains to the cloud security. The CSP is responsible for security of the cloud, and the client is responsible for security in the cloud. So let's remember that when you talk about the physical aspects of the data center, when you're talking about one of the CSPs, they're responsible for all of those things. But when you're talking about what users have access, that is up to the customer. So that's that shared responsibility model. Next, we want to understand what disaster recovery is. So disaster recovery is the ability to become operational after a disaster happens. Disasters can include natural disasters, cyber attacks, hardware, software failures, or human error. Next, we want to know how redundancy works in the cloud environment. So cloud providers can provide redundant systems, which is like fault tolerance. This means if one component of the system fails, there's no loss of functionality because the redundant system takes over. Redundancy can apply to hardware, software, network infrastructure, geography, processes, or data. Next, know what an RPO is. A recovery point objective specifies how old data can be and still be considered current or useful to restore normal operations. So remember, we're talking about RPO or RTO, which I believe is the next one. We're talking about based off of conversations with the business to determine what that objective is. So these are agreements that are made. And in the case of an RPO, it's an agreement that says this is how old data can be, and it will still consider it okay. If you'll remember, I talked about back in the 90s, we very well might be able to tell an engineering group, say, sorry, you have to redo everything that you did yesterday. That was acceptable back in the 90s. Nowadays, that is not acceptable at all. As a matter of fact, some people get agitated if you said you just lost your last 5 minutes of work. So it just depends what your business and the IT department has determined what that objective is. And then finally, the RTO, and the same thing as the RPO, but this one is recovery time objective. And it defines how long the system or services can be down before being restored. So in the event of a disaster or an outage, you need to know how long is it okay for the systems to be down. If it's some system that you just need to do daily operations, it very well, like in the event of a disaster, it might be acceptable. But if you're talking about a system that people need access, like a weather app or email, or something that is out there in the consumer market, that of course is going to have a more distinct RTO, and you're not going to be able to say, oh, we don't need to work to get this back up. In some cases, it says there's no excuse, we have to be up and running. There are a lot of concepts in chapter 1. So especially if you're new to the material, you might need to spend a little bit more time reading through it. You don't want to go forward. It's okay if you don't understand everything at a great detail, but I want to make sure that you have a very high level understanding of everything that we did have there. Now, we're about to go through and do some exam questions and the written lab, and we'll go through that. And so this is a time of review. So make sure before you start this review that you have gone back and read chapter 1 on your own, made some notes, and understand that even if you don't get everything right now, you know what you do need to read before what you need to review and what you really need to memorize before you're ready to take the certification. So take that time now, and then we'll be back. Okay, so each chapter has a written lab in the end of it. And these are really good labs. It's a way to make sure that you have all the information. And so it's definitely meant to be after you've read the material and after you've studied it to sit here and go through it. You want to be careful not to just memorize answers because that's not what we're in here for. We're trying to learn the material, make sure that we can go take an exam and show that we understand each of these. Now, some of it is going to be some memorization, but use these labs to jot down notes and know that the things that you do need to still memorize. So we'll jump right in here. Number one, the blank specifies the oldest data can be to be acceptable to restore for business use. We just went over this, so we know this is the RPO, or the Recovery Point Objective. Number two, Microsoft Office is an example of the blank cloud service model. So we're talking about Office 365, Google, those things. What is that? Software as a service. Number three, cloud security responsibilities are defined by the blank. If you'll remember, this is when we talk about the shared responsibility model. This is what we know that the cloud service provider is responsible for what is of the cloud, and the consumer, the person that's running it, is responsible for what's in the cloud. Number four, cloud users need to access resources from PCs and mobile devices. This is also called broad network access. And then cloud clients can get more compute power without CSP intervention based on the blank characteristic. This would be the self-service characteristic. Number six, the blank cloud deployment model places all security responsibilities on the company that owns it. This is the private. So remember, private means you own everything. It's in your data center. And there may be cloud components, but you're not going to the big guys to buy them. They're the ones that you've split up. You have your own hypervisor. You're running everything inside your own data center. Then number seven, thanks to the concept of pooled resources, cloud resources are said to be elastic. Number eight, an SLA that specifies 5 nines is referring to high availability. Number nine, 1 month, a cloud client uses twice as many resources as they do normally. The next month, their normal amount. They pay for what they used. This is called pay as you go. And then finally, number 10, the two recovery objectives that should be in a disaster recovery plan are the recovery point objective and the recovery time objective. Each chapter ends with review questions. Remember, these are also in the slide deck so that you can go through these and have these and use them like flashcards. We may even think about putting all of these together so that you'll have them just in one place. But for right now, they're at the end of every chapter's slide deck. You're going to find the written labs and then the review questions. So the CIO wants to reduce the cost of network ownership for the company, specifically for app licenses. Which service model would you recommend? Well, in this case, it's going to be in SaaS, software as a service. So which of the following is a potential outcome of implementing a multi-cloud environment for your company? In this case, it's going to be D, increased flexibility of using separate SaaS and IaaS vendors. You are buying a new cloud service. The internal network administration team is worried about cloud access for different OSs, such as Windows, Mac OS, and Android. What should you tell them? In this case, our answer is C. Resources will be available to all clients' operating systems via broad network access. The company CIO asks you to ensure that the new cloud solution provides fault tolerance. Which aspect of cloud design does this refer to? Redundancy. Which of the following are examples of infrastructure as a service that a cloud provider might offer? Choose two of these. Compute and storage. Now, there are some cloud providers and documentation that suggest that that database goes in there. It doesn't always. It just depends. But the ones that we know for sure here are the compute and storage. Which of the following should you ask for in an SLA if you want to ensure the highest availability of resources for cloud users? This is the 495s. No, 495. When shopping for public cloud service, the CSP tells you if your company needs more or fewer resources, the CSP can instantly accommodate that. What cloud characteristic does this refer to? Elasticity. Your CSP makes daily backups of important files and hourly backups of an essential database, which will be used to restore the data if needed. Which aspect of cloud design does this represent? C. Disaster recovery. Which of the following best describes the purpose of the shared responsibility model? This is going to be A. The CSP and the client share responsibility for cloud security. Which of the following cloud service models best supports a software development team with members in the United States and Japan? This would be platform as a service. You're negotiating an SLA with the CSP. Which two things need to be included as part of the recovery objectives? This is recovery point objective and also recovery time objective. In the cloud security model, who is responsible for securing access management and firewall configurations? This is going to be A, the CSP. Which of the following cloud deployment models offers the best scalability and cost effectiveness? This is going to be A, the public. Which of the following best describes an RTO? It's going to be B, the amount of time services can be down after disaster before being restored. Which of the following is not a common characteristic of public clouds? Higher cost, of course. Your company uses a financial transactions database that updates frequently. If a natural disaster occurred, any data backup older than 1 hour would not be useful to the company. To ensure that backups are always more current, what needs to be specified in the disaster recovery plan? That, of course, is the RPO. Your network hardware is outdated and needs to be replaced. The CIO suggests using the most cost-effective cloud solution. However, he insists that the company database remains 100% controlled by your company. Which solution is your best choice? This can be the hybrid model. Your data science team runs complex simulations that require more compute resources. They do about one simulation per month, and it takes 1 or 2 days. You want to ensure that the team has available compute resources, but that you only pay for the resources when they are in use. What cloud characteristic do you need? This, of course, is pay as you go. Which of the following is not a type of redundancy typically available in public cloud solutions? This is operating system. You can definitely have redundant hardware. You can even have redundant servers, but the actual operating system not going to be redundant. Several universities want to band together to get cloud service. They want to share scholarly research, but also take advantage of common cloud-based productivity apps. Which solution is best option for their needs? Community. All right. I believe that is everything in the chapter. So at this point, we'll wrap this up and move on into chapter 2.